assure you that what you will observe is a vast wasteland.
Free and uncorrupted communication.
I remember an engineer I talked to once on his retirement, and I asked him what he'd learned after his long career in the public life, in serving the public, and he said, well, the soil conditions are always better on the poor side of town. And then I've run into lots of other people who say, well, okay, maybe poor people can't protect themselves as well, but surely there can't be a racial component to this, can there? And as I mentioned earlier, probably the best known of the scholars and scientists who've worked on that is Professor Anderton from University of Massachusetts at Amherst, who concluded that, no, it was just income, it couldn't be race. And we invited him, and he said that, well, actually the better work being done right now on quantitatively looking at every way you can probably try to make those racial disparities go away would be Paul Mohai, who happens to be our next speaker. He's a professor at the University of Michigan, but there's something more important about him that you need to know here. There's an old saying in academia that power corrupts and PowerPoint corrupts absolutely. Paul has been resisting PowerPoint for his entire career, and he had planned to do his entire presentation today with overheads. I heard from Ray Tracy about an hour before this session started that if we did overheads, UCTV wouldn't be able to record much of anything. So he and I were frantically spending about 48 to 53 of those minutes of that last hour before the presentation trying to transfer all of his overheads onto PowerPoint slides, and you will see, I believe today, the very first PowerPoint presentation ever made by Professor Paul Mohai. Paul?
Thank you. Well, I'm glad Bill mentioned that because I do feel like a newbie here. Bill said all I got to look for is the keys with the arrows in here, and he would help me if I couldn't find them. So
the space bar will work too.
The space bar, okay. All right, and how do you go backwards?
You don't have to find the arrows. There'll be a momentary pause here.
I was perfectly happy with those overheads.
These arrows.
Oh,
so
thanks.
Down, up.
Okay, thanks very much.
This is high.
All right, we'll see if this works. I was amazed at how quickly Bill could scan these in. I mean, we got these in like 25 minutes, and you know, I had a cup of coffee because I like to be sort of, you know, I like to have a little bit of an edge when I give a talk. And I told Bill, I said, you know, I didn't have to drink that coffee. I mean, I'm, you know, just on the edge of my seat. Are we going to make it? Anyway, it looks like we made it, and I'll see how this turns out. First, I want to thank Professor Freudenberg for inviting me, and I feel very honored to. I'm sorry. Can people hear that now? Okay. I also I wanted to say that I feel honored to be speaking with both Professor Freudenberg and Professor Bullard. I consider them among the two most influential environmental sociologists today, and I want to acknowledge particularly Professor Bullard's work because when I first became interested in this topic, it was because of my interest in wanting to know more about African American attitudes about the environment, and this was in the mid to late 1980s. And the conventional wisdom back then was that African Americans are not concerned about the environment, or at least not as concerned about the environment as whites. And but when I went to, I had a good data set, and we'll get into that data set, but I knew I needed more than a data set. I needed some hypotheses. I want, you know, the standard academic thing. You want to make a thorough literature review. And I just had the hardest time finding anything. And I came across Professor Bullard's work, including his very early paper in 1983, the study that he had mentioned earlier, looking at sanitary landfills in the Houston area. And when I really started working on this in earnest, it was about the time I started at University of Michigan, which was in '87. And back then, they didn't have a computerized library system. For those of you who can think back that far and can, remember computer punch cards and library cards and trays and everything, you just couldn't search authors, keywords or anything. But what the university had at the library were specialists. So if you told them what you're looking for, which amounted to giving some names and keywords, they had a system. I don't know what system they had that wasn't available to anybody else, but these specialists, which are probably, I suspect, in retirement now, would do the search for you. So I already had all the articles that I could find of Professor Bullard's. And when I first told him, I got all, these works by Robert Bullard and Beverly Wright, and this is what I have. They said, okay, well, come back tomorrow, or we'll call you. I forget exactly how that worked, but 2 days later, they said, oh, we found a whole bunch of stuff for you. So they showed me the stack of stuff. And it was all the articles I already had from Professor Bullard. And I did this a couple of times, and finally I said, okay, I'm going to make sure next time I go to the library, I'm going to get another specialist here, because maybe with some other, person who's familiar with different kinds of things or thinking a little more creatively, they might find something else. So, but it was the same thing. All the work came back to Professor Bullard. So I felt not frustrated, but I felt I had sort of covered all the literature that seemed to be out there, but I was frustrated that I couldn't find anything more. So I thought I'd give this guy, whoever he was, Robert Bullard, a call. And boy, that was the first time I got to realize what a jet setter he was, because I could not track him down. I started with where he was in the one article, and I called that institution. They referred me to another one. I call that one. They referred to me another institution. I finally think I tracked him down at UC Berkeley or UC Riverside. Was that the other place? So anyway, I finally got a hold of him, and we had a good talk. I don't know if Bob, you remember that talk, but I remember saying to him, I said, this is really interesting stuff. How come there aren't more people working on this? And he said, well, I forget exactly what you said. Maybe you remember, but I do. What I remember was his reaction. It was sort of like he was surprised that I was surprised that I couldn't find anything. And so anyway, I knew that this is virgin territory at the time. So anyway, but I just wanted to acknowledge him, because I think that there's no question that his work was very influential on me, and I feel sort of privileged that we all got to know each other while we were still relatively young men, which we still are, but we were a little younger back then. So anyway, well, let me get into my talk. I think Professor Freudenberg had mentioned, I'm mostly a quantitative researcher, and I come at this issue mostly as a quantitative researcher, and I've been doing my own research for some time. And in the process of doing that research, I, of course, have been trying to follow the quantitative research that other people have been doing. And I would say that by now, there's easily over 100 quantitative articles or quantitative studies pertaining to racial and socioeconomic disparities in the way that environmental hazards of a wide variety are distributed. And several things I've done. I did an early review in 1992 with my colleague, Professor Bunyan Bryant, and there have been several other reviews since, the most recent one being published in 2005 by Evan Rehnquist, a political scientist at Indiana University. And these reviews and my own review show a fairly clear pattern that the vast majority of quantitative studies show statistically significant racial and socioeconomic disparities in the way that environmental hazards of a wide variety are distributed. But having said that, I also noticed that there was quite a bit of variation in the magnitude of these disparities that have been found, and in fact some studies have found none, and Professor Freudenberg mentioned the studies that were done at the University of Massachusetts as being one of them. The other thing that I noted in doing these studies, and this is where I embedded it in the title of my talk, which came first, People or Pollution, is that in terms of the quantitative research, it's really not yet well understood which came first. And when I asked the question of people or pollution, I mean, were people of color communities and poor communities already where they are before the hazardous waste sites and polluting industrial facilities and other locally unwanted land uses were brought in? Or was it the case that there was no was it the case that the hazardous waste sites, including industrial facilities, were there first, and poor people and people of color moved in after them? Some people have referred to this as the chicken or egg question in environmental justice, and I think it's an important question in terms of a first step in terms of testing hypotheses about cause and effect relationships. One of the things that I found is that there's only about 6 studies. I don't think that's an overstatement or understatement. I don't know which direction that is, but I'm pretty confident there's only about 6 studies that try to tackle that question. And to tackle that question, what you need to do is longitudinal analyses. You've got to look at what the demographic characteristics were at the time the facilities were sited to see if there was a pattern of disproportionate or discriminatory siting. And then you have to look at the demographic changes after siting to see whether those demographic changes lead to greater disparities. As I said, there's only about 6 of those studies out there, and unfortunately they all run into contradictory findings. I would not say that there is any study right now that really conclusively answers that question. And because of all those ambiguities, it caused me and my graduate students to take a hard look at the methodologies used in these studies. And one of the things that I found, and we found, was that the vast majority of quantitative studies tend to be of a particular type. Now, this particular type of study is what we've been calling the unit hazard coincidence method for reasons that I'll explain in a minute. But it's as I said, it's the most widely used. It's so widely used. We tend to, in our own writings, we tend to refer to it as the traditional or classic approach, and it certainly is the approach that the influential national studies have used. Now, why I get so excited, or in my case, why did I get excited about discovering this pattern? Well, when we took a hard look at that particular approach, we found that it doesn't do a very good job, really, of controlling for proximity between environmentally hazardous sites and nearby residential populations. And if the environmental justice argument is true that there's a disproportionate number of people of color and poor people where these environmentally hazardous sites are located, then this method would actually wind up underestimating or overlooking them, and maybe that's why we get the variation in ambiguity in these findings. Maybe this is why Professor Anderton at University of Massachusetts got the particular findings that he did. So, what I'm going to do in my presentation, okay, Bill, I used that arrow, nothing happened. Hit the space bar. Thank you. All right, so in my presentation, this is what I'm going to do. I'm going to demonstrate how and why this particular method fails to control for proximity. And I'm going to also talk about alternate methods we've been terming distance-based methods, which do a better job of controlling for proximity. And I'm also going to show how when you use those methods, the assessments about the magnitudes of the racial and socioeconomic disparities in the distribution of hazardous sites are changed. And then finally, I'm going to get to that chicken or egg question, and that is, by using these methods, I'm going to try to answer this question, which came first, people or pollution. So let me, well, okay, great. So let me describe, first of all, this classic method. Now, it's actually a very easily understood method. Once the researcher decides what kind of environmentally hazardous site they want to examine. Let's say we're looking at hazardous waste treatment, storage, and disposal facilities, TSDFs for short. Once the researcher decides what kind of environmentally hazardous site they want to examine, the next thing is to pick some kind of geographic unit of analysis. And most of the studies have used either zip code areas or census tracts. Sometimes people have used counties, sometimes cities, sometimes even states. But the most common unit of analysis has been the zip code area or census tract. Now, once that decision is made, then the researcher determines which of the units contains the environmentally hazardous site of interest and which units don't, and then they simply compare the demographic characteristics of the two sets between the host and the non-host. And that pretty well describes the unit hazard coincidence method. Notice that, and I have this on the slide here, is that what it does not do, it doesn't look for the precise geographic location of the site within the unit. and neither does it look at its proximity to nearby units. It just looks to see whether the unit and the hazard are coincident. That's why I like the term unit hazard coincidence. The distance-based method, and as I said, most environmental inequality studies not only have used this approach, the most influential national level studies have used this approach. The alternate methods, which we've been terming distance-based methods, do take into account the location of the environmental hazard and proximity to nearby populations. And I have labels for 3 of them: point containment, 50% areal containment, and areal apportionment, but I'm not going to bother defining them because it's just easier to show you by examples rather than give you an abstract description. Okay, so just to show you both what this method is all about, why there are problems with it, why it doesn't do a good job of controlling for proximity, is that this bill is where I'm so used to moving around, and I've got to stay with this. Does this mic come off by any chance? Okay. All right. Now I really feel like an entertainer here. Okay. I don't know. I just feel more. It's a short. Okay. I got some space. Short leash. Okay. I'm going to probably pull that out, and everything will come down. Okay. All right. This is great. This is a realistic census tract map of of a metropolitan in the eastern United States. These triangle things here, those are hazardous waste facilities, and these jigsaw puzzle pieces, they're census tracts, and the 2 shaded tracts, of course, are the tracts hosting the facilities. Okay, now just imagine a census tract map covering the whole U.S. And just imagine all the tracts that contain a hazardous waste facility. Imagine you've shaded all of them. Okay, then the unit hazard coincidence method, just imagine yourself comparing the demographic characteristics of the shaded areas with the non-shaded areas, and you've got pretty well the method. And it sounds, I think, very intuitive, and the assumption that the researcher is making is that people living inside the host tracts are living closer to the facility than people living in the non-host tracts. But is that really true? Okay, well, let's look at this example here. If you look closely here, you'll see that those 2 facilities are actually pretty close to the boundary of their hosts. And if you look carefully enough, I just lost that little, see, I'm the quantitative researcher, but I'm having all these technical difficulties. Okay.
You want to try this one?
Thank you. Bill, you want to? Thank you. All right. Great, this works. If you look really closely where those facilities are located, you can see that they're pretty close to some of the adjacent tracts. In fact, most of the area of those 2 tracts look like they're as close to that facility as most of the host tracts proper. Likewise, these several tracts down here look like they're as close to that facility as most of the host tract proper. Now, if the environmental justice argument is correct, that there's a disproportionate number of people of color and poor people near where those facilities are located, wouldn't it make sense that the demographic characteristics of those nearby tracts are more similar to the hosts than they are to other non-host tracts that are tens or hundreds or thousands of miles away? I think it would make sense, but the unit hazard coincidence would take those tracts and make no distinction among those compared to the tracts out here or much further away. They get lumped in with the comparison group of tracts. Okay, so that's one thing that's wrong with this method. And by the way, just to let you know that I didn't show you the 2 exceptions, the 2 tracts that were at the boundaries. My students and I measured every one of 608 hazardous waste facilities in the country to the boundary of their host tracts, and we found that 49% of them are within a quarter mile of their host tract boundary, and about 71% are within a half mile. So we're talking about a substantial number. Now, this is not the only problem with this method, but before I go and talk about the second major problem, this is a good point to show you those 2 distance-based methods. This one we call the 50% areal containment method, because what we did here was centering a circle at the facility, we drew a circle of 1 mile radius, and any tract, not just the host, but any tract where at least 50% of the area is captured by the circle, we considered it as part of the host neighborhood. So now we've picked up these 2 tracts that would have otherwise been put in the non-host group. Here we pick up 4. So rather than having only 2, presumably affected tracts we now have 6. So we're going to compare the demographic characteristics of all the shaded areas against all the non-shaded areas. Okay, that's the 50% areal containment method. This is the other method that we like. This is my preferred method for reasons that maybe I can convince you about, is that it's somewhat of a refinement over the other one. In this case, in the previous case, a tract gets either included all in or all out, depending on how much of it, or, depending on whether or not 50% of its area is captured. Here, every tract that gets intersected by the circle, see like that one there, contributes some weight to the calculations. And the way this works is that, say, let's say 10% of the area of the tract is captured. We're going to take 10% of its population and count it into the middle. If 75% of the area of the tract is captured, we're going to take 75% of its population. So you see how that works? So the demographic characteristics that we're estimating within the circle are essentially a weighted sum or aggregation of the populations of the intersected tracts, where the weights equal the proportion of the area of the tracts captured. Now, as you're going to see, and we found we used different units of analysis here. We used smaller units like block groups. We used zip code areas. We used different radii, 1 mile, 2 mile, 3 mile. We went all the way out to 15 miles. Regardless of which method you use, that 50% areal or containment or areal apportionment, we found there was striking consistency in the results. So they're very robust methods. Okay, now, so those, I showed you one problem with this method, and I also showed you the 2 distance-based methods. Before I show you the next slide, here comes the other problem with the unit hazard coincidence method, and that is that there's a great deal of variation in the size of the geographic units of analysis used, whether we're talking about zip code areas or census tracts. And this is something that's not been recognized in the published literature. We found that the smallest tract containing a hazardous waste facility is less than 1/10 of a square mile. So you know that anybody who lives in that tract is going to have to live necessarily pretty close to that facility. But what do you suppose the largest facility or largest census tract is containing a hazardous waste facility? How many people thought hundreds of square miles? Okay, some people. Well, you'd be wrong. The biggest tract is actually in the thousands of square miles, and I'll show you, and that's that one there. This tract here is 7,500 square miles. And there's a triangle, and that little dot there, that's the same circle of 1 mile radius that you saw before, but obviously shrunk so I can get it on one page. That facility is 34 miles to the center or centroid of that tract. Now, what's wrong with this picture? What's wrong with a situation like this? Well, I think it's hard to argue that the majority of people in that tract live within that 1 mile circle. I think it's more logical to assume that most of the people in this tract live far from that facility. And if they do live far from the facility, is there any particular reason to assume that the presence of that facility is causing a disproportionate number of people of color and poor people in that tract? There may be a disproportionate number of people of color and poor people in that tract, but it won't be because of that facility. Again, imagine 34 miles. Think of where 34 miles is, and would you be worried about a hazardous waste facility 34 miles away? And just to show you that I didn't show you, again, the only exception, this is the, and there's more than this, but Professor Freudenberg only got to scan in 2 before we ran out of time. But this is the largest census tract hosting a facility in a metropolitan area. And here's the same, here's that triangle, and here's a circle 1 mile radius. Now this tract is a lot smaller. This is about 860 square miles, and it's about 20 miles to the centroid. And so it's smaller, but I guess I would argue that most of the people in this tract probably don't live within that 1 mile radius. They're probably living pretty far away. So our hypothesis is because these large tracts are not doing a good job of controlling for proximity, we're not going to see a lot of people of color and poor people necessarily in those tracts. Okay, so summarizing. Principal causes of the classic method, including the national studies that have been so influential. Number 1, it does not take into account the association of the presence of an environmental hazard and the characteristics of adjacent and nearby units. And number two, it gives too much weight to the very large host units where an association between the presence of an environmental hazard and the characteristics of the unit is not likely. Okay, now I just showed you some examples, and it was just to clarify my argument, but that would not be proof. That's not evidence alone. So what we did was we looked at all the hazardous waste facilities in the US, and what we did was to look at the three methods. We looked at the unit hazard coincidence method, we looked at the 50% areal containment method and areal apportionment method, looked at the sizes of the neighborhoods created by each of these methods, and then compared them. And basically what I'm going to show you here by using this sort of more quantitative and comprehensive way of examining these neighborhoods, that when you use one of the distance-based methods, you're actually defining neighborhoods that are getting a lot closer to the facility. So let me just show you here. First of all, here's the great range in the size of the census tracts, as we said before. Here's the mean area, about 74 square miles. Here's the median, 5 square miles, so it's skewed towards the smaller tracts, but there are a lot of large tracts here. Here's the standard deviation, so there's a great deal of variation that's as suggested by the range here. So this is just sort of baseline. What am I supposed to get out of it, you're wondering? Well, this is just baseline. We're going to see why this is important when we look at the same measures for the other two distance-based methods. We also looked at the distance of the facilities to the centroids of the neighborhoods. Here you see, again, a great range here. Here's the average distance, of about 2 miles, the median distance, which is 1 mile, and here's the standard deviation. Now, if we look at those exact same measurements with the two distance-based methods, you'll see how much smaller and how much more consistently sized and configured the neighborhoods are using the distance-based methods. So for the 50% areal containment method, you see a smaller range. The biggest neighborhood is 5.6 square miles. Here's the mean area, 2.5 miles. Again, compare that with the average size for the raw host tracts. Here's the mean, median. Again, the mean is a lot smaller here. Median is smaller, and the standard deviation is smaller too. So what this says is we're getting closer to the facility. They're smaller neighborhoods, and not only that, they're much more consistently configured than with the raw host tract. For those of you who remember your high school algebra, the area of a circle is pi r squared, so 3.14 is pi, radius is 1, so that's why we get 3.14 in every case, because we're creating perfect circles each time. So again, we have smaller neighborhoods. They're always centered at the facility, and the standard deviation is 0 because that's the way we define it. So essentially what this quantitative analysis shows is that we're getting smaller neighborhoods, we're getting closer to the facilities, and so the question now is, does proximity matter? If the environmental justice argument is true, that there's a disproportionate number of people of color and poor people near where these things are, I think that we should expect that we would find that by using the distance-based methods, we would get larger proportions of poor people and people of color. So in our next analysis, we looked at a range of demographic variables: percent African American, percent Hispanic, percent non-white, percent living below poverty, mean household income, and some other things. I'm going to just focus your attention on the non-white percentage and the poverty percentage, because I think they show pretty well the pattern in the other numbers. The first thing we did, again, for baseline, we looked at the demographic characteristics of all the host tracts taken together, and we looked at all the demographics of all the non-host tracts in the U.S. taken together. And as you can see, if we look at the non-white percentage, as hypothesized, there's a larger percentage of non-whites in the host tracts. But that difference is only about 1.2%. So it's bigger, but not all that much bigger. Likewise with the poverty percentage, it's bigger, but it's bigger by 0.5%. If we look at in this case, the 50% areal containment method, and we look at the neighborhoods that are defined by a 1 mile radius, we see that the non-white percentage is a lot bigger. It's 46.2% versus the 25.4% we got when we used the unit hazard coincidence method. Likewise, the poverty percentage is greater, 20.6% versus 13.6%. And we get similar numbers if we use the areal apportionment method. I told you that they come out consistent. If we use smaller geographic units like block groups, those numbers actually get even closer. There's one more thing that we did to show how controlling for proximity makes a difference. We looked at the host tracts that were too big to be captured. So those are the tracts where most of the area lie beyond the 1 mile radius. And notice not only that the non-white percentage and poverty percentages are lower than what's inside the 1 mile radius, but notice also that those percentages are smaller than we look at all the host tracts taken together. So in other words, when we use this method, we're sorting the tracts based on their size and their ability to control for proximity. Again, these are smaller than here, so that as we had hypothesized, the large host tracts don't do a very good job of controlling for proximity. Or we hypothesized that the large host tracts, we would have fewer people of color and poor people in them. Okay, that's a descriptive analysis. We did one more thing. Yeah, I forgot about this one. That we also compared our results, that's our results here, with the other leading national level studies. This is the 1987 United Church of Christ report. This is Professor Anderton's study. And this is Professor Vicki Bean, replicated Anderton's study, but constructed her comparison populations differently. They didn't get statistical significance here. Bean did, but I think if you look closely, there's a 3 percentage point difference. We've got almost a 20% or more difference there. We did one final thing with our quantitative analysis here. We wanted to see how using distance-based methods would change our assessments about the relative importance of race and socioeconomic factors in predicting the location of the facilities. So we did a logistic regression analysis. It's a multivariate technique where the dependent variable is dichotomous, and which means the answer is either yes or no, or the values are 1 and 0. So what we did was I'll explain how this worked in a minute, but we looked. These were the independent variables that we looked at: percent African American, percent Hispanic, mean household income, mean property values, percent with college degrees, percent employed in executive management and professional occupations, in other words, people in the upper end of white-collar jobs, and percent employed in precision production, transportation, or labor occupations, i.e. the people employed in the blue-collar jobs. Now, when we did the logistic regression using the unit hazard coincidence method, the dependent variable took a value of 1 if a census tract had a hazardous waste facility in it, and it took a value of 0 if it did not. When we used the 50% areal containment method, the dependent variable took a value of 1 if a tract was within a mile of a hazardous waste facility, and it took a value of 0 if it was further than a mile from the facility. And then we compared the results. In the first regression, using the standard 0.05 level cutoff for statistical significance, we found that neither of the race variables were statistically significant predictors of hazardous waste facility location. And the only 2 variables that were statistically significant and predicting the facility location in the right direction were the people in percent employed in white-collar jobs and percent of people employed in blue-collar jobs. So if a researcher getting this kind of result would interpret it the following way, that any initial racial disparities that were found in the descriptive bivariate analysis are essentially explained away by the occupational variables. That hazardous waste facilities are located where blue-collar workers live. And to the extent that people of color are more likely to hold blue-collar jobs than white-collar jobs, that explains the racial disparities in the bivariate analysis. And this is pretty much the interpretation that was given by the study coming out of the University of Massachusetts. Now, if we use the distance-based method, what happens is that both race variables are highly statistically significant predictors of facility location. This is at the same time that the socioeconomic variables remain statistically significant, or in some cases they actually increase in statistical significance, like percent with college degrees. What's happening here is the race variables are remaining statistically significant even when you're controlling for the same socioeconomic variables. And so an interpretation of those results would be that the initial racial disparities that were found in the bivariate analysis are not explained away by the socioeconomic variables. There's something about race, something uniquely related to race that is accounting for the racial disparities. What are they? Well, this statistical analysis it's not enough to be able to pin that down, but some possibilities, of course, are that people of color communities are targeted for hazardous waste facilities, or once the facilities are located there, housing discrimination keeps people of color from being able to move away. Okay, so just to summarize, now this is part one of my conclusions, and the second part, I know that I'm giving a lot of quantitative information here. Next part is I don't have as much on this, but just to sort of take stock of where we are, the conclusions from that analysis are that the classic method fails to control for proximity, and it fails to control for proximity in two ways. One, it ignores nearby units, and number two, it gives too much weight to the very large units. The distance-based methods overcome the problems that we saw up here, and if we control for proximity by using distance-based methods, they reveal greater racial and socioeconomic disparities in the distribution of hazardous waste treatment, storage, and disposal facilities than what previous studies have shown. And then finally, controlling for proximity in multivariate analyses suggests a strong independent effect of racial factors in the distribution of the hazardous waste facilities. Okay, so what I've shown here is that the old method, a lot of the ambiguity in assessing the magnitude of racial and socioeconomic disparities is the result of using methods that don't do a good job of controlling for proximity. And I think I mentioned that that same failure of controlling for proximity has led to contradictory results about which came first, the people or the pollution. And again, some people call this the chicken or egg question in environmental justice research. With the distance-based methods, because they produce more reliable results and they provide consistently sized units for the neighborhoods, we can do longitudinal analyses now to answer that question. Let me just add a little bit more to that chicken or egg question. The vast majority of quantitative studies on environmental justice, what they do is they take the most recent data on facility location, they take the most recent census data, and then examine those data to look for the disparities. And if they find the disparities could come about in two ways, as I mentioned earlier. One is that at the time of siting, there was a pattern of disproportionately putting them in people of color communities. We've been terming that discriminatory siting. Some people say don't use that term because it confuses people. I'm using it in the sense of Joe Fagan, who defines discrimination as an outcome, not an attitude. So, you know, Professor Fagan, his argument is that you have discrimination and discriminatory outcomes if the action leads to a disparate result, not necessarily that there was any racist intent. So it's not an attitude, it's an action. So that's one possibility. There's a pattern of disproportionately or putting these kinds of sites in people of color communities. Now, the other possibility is that there's no pattern of discriminatory siting. Affluent white communities are just as likely to get a hazardous waste landfill as anybody else, but once it's been placed and its impacts are felt, it lowers the quality of life, lowers property values, and will cause some people to leave. Well, who gets to leave? The people with higher incomes and generally more affluent white communities. They have both the means and the ability to leave, and they'll leave. People of color, because they have less financial resources, are trapped, or housing discrimination might be a further constraint on their leaving. So there's no. So the possibility is that there may be no pattern of discriminatory siting, but after siting, there are post-siting demographic changes that lead to the disparities, and of course, both things can happen as well. So what we did using the distance-based methods, and by the way, everything I showed you previously will be published in an article in May in Demography, but this is this is unpublished stuff. So this is, I think, the first group to see this, actually. What we did to try to test that chicken or egg question was We grouped the facilities in our study by the dates they were established. And since the census only occurs once every 10 years, what we did was we grouped the facilities that were sited nearest to each one of the census decades. So in this analysis, what you see are the facilities that were sited between 1966 and 1975. And we did two things, and the dashed line is sort of our reference year. So these were the facilities that were sited near 1970. Two things we did. We looked at, is there evidence of discriminatory siting at the time of siting, and then what happens after the siting? Are there post-siting demographic changes? What we did here in this particular analysis was we broke out each of the racial and ethnic groups. So, for example, these two graphs pertain to just the white population. And this solid line right here represents the percent of whites living, or not the percent of whites, but it's the percentage of people within 3 kilometers of a hazardous waste facility sited between 1966 and 1975 who are white. And this dashed line represents the percent of people living further than 3 kilometers away who are white. And what you can see here is that there are fewer whites proportionally in the 3 kilometer areas around those facilities. And so just looking at the white population, is there evidence of disparate siting or discriminatory siting? I would say if you just look at that one datum, the evidence is that there's a disproportionality there. But what happens after siting? Those disparities increase further. So if we just looked at the white population and just looked at the facilities sited between 66 and 75, in terms of getting an answer to the chicken or egg question, it looks like it's both. You know, the people, you know, there's disparate siting at the time of siting, and then there's increasing disparities afterwards. Now here's some of the interesting things that come in here. If we look at each racial and ethnic group, and I couldn't include them all because their numbers are pretty small, particularly back in 1970. So I looked at African Americans and Hispanics first, and then later the Asian population when they started registering in bigger numbers in 1980. If you look at the African American population, this is the percentage of African Americans living within 3 kilometers of one of those facilities. And this dashed line is the percent that's living farther than 3 kilometers away. Obviously what you see here is that the lines that you saw up here are just reversed. And what you also see here is, so there's larger numbers proportionally of African Americans living within the 3 kilometer area than those living further away. You see that there's evidence of disparate siting here. And if you look closely, the African American population increases somewhat between 70 and 80, levels off, and then decreases again. So that in the end, the disparities in 2000 are not that much different than they were in 1970. So in effect, this is saying that, well, in terms of the chicken or egg question pertaining to African Americans, we see evidence of disparate siting at the time of siting, but not much evidence for post-siting demographic change concerning African Americans. If we look at the Hispanic population, we see evidence of disparate siting, and we also see that the disparities increase over time. So there's evidence for both processes for Hispanics, and I won't comment on the Asian population because there's just not enough data there. Okay. Whoops. All right. This graph represents the results when we do the same analysis for facilities sited between 76 and 85. Those facilities cited closest to 1980. So I put a dashed line as to the reference point we should be looking at. What do you think? Do we get the same pattern as before? Looking at that quickly. I think for the white population we see it's true. And the disparities increase over time. So it's similar to what we saw before. If we look at the African American population, evidence of disparate siting, but the gap actually closes a bit in that, from 1970 to 2000, that 30-year period. So again, we have evidence of disparate siting for African Americans, but no evidence for post-siting change. If we look at the Hispanic population, again, we should be looking at this as a reference year. We see evidence of disparate siting, and the disparities increase over time. So it's like we saw before. And for the Asian population, it's sort of hard to tell. There's a disparity there, but those numbers look close, but they're small numbers to begin with. We didn't test yet to see if they're statistically significant, but they look like the disparities there, and there's post-siting change. So what's going on for the Hispanic population and the Asian population is different than it is for the African American population. Now let me show you one other thing. The common interpretation has been, this chicken or egg question is either the facilities are being placed disproportionately in African American or other people of color communities, or the facility causes negative impacts and some people move out and some people will either stay or move in. We get actually a different interpretation when we look at the patterns from this particular graph. Notice that the areas around those facilities are already in demographic transition before siting. That's almost a perfectly straight line. It doesn't look like the facility had any impact on the surrounding neighborhoods. It was already, whites were already, the percentages were falling. And similarly, if we look at the Hispanic population, the numbers were already increasing before facilities were placed. Let's see if we get the same pattern in the next graph. These are the facilities that were sited after 1985, and since out of those 84, only 2 were sited after 1995. We just said after 1985. Notice that we see evidence of disparate siting as before. We see post-siting demographic change, but like before, those communities are already going through a transition. They're losing whites in proportion to other racial and ethnic groups. Notice this time for African Americans, there's this evidence of disparate siting, but this time there's post-siting demographic change. But I would argue that it doesn't look like the facility caused that change. That community was already transitioning. There were larger proportions of African Americans in that community. Likewise, when we look at the Hispanic population, again, evidence of disparate siting, but that community was going through demographic change. And now this time we can also look at the Asian population and see the same thing. And I had a bunch of other overheads that Professor Freudenberg did not have time before. We were both breaking out into a sweat like 2 minutes before 3 o'clock. But we also my graduate students and I also looked at why those percentages are changing. In other words, those percentages could be changing for a lot of different reasons. They could be because whites are moving out, people of color are moving in. It could be that maybe both whites and people of color are moving out, but whites are moving out at a faster rate because they have more resources and don't have to face housing discrimination. So we looked at all those numbers, and the patterns look pretty much the same as you see them here. It looks like for the African American population, there's no much net movement in or out of these areas, but Hispanics and Asians are moving in, and the white population, again, in absolute numbers, are moving out. But as before, the patterns show that the transitions are already taking place. So, which came first, people or the pollution? I would say it's the people. I think the longitudinal analyses reveal clear patterns of disproportionate siting of hazardous waste facilities in people of color neighborhoods. Although the racial disparities around hazardous waste facilities also increase after siting, these changes may be linked to changes already taking place before siting rather than being the result of siting. And finally, these patterns only become evident because of applying the distance-based method. So what you see here is the first national level longitudinal analysis, and I think the results here are pretty clear. So thank you for your time. Sorry for the technical difficulties here, but I appreciate everybody's help with this.
What are the magnitudes of these several populations? Because there'd be some drag effect.
I'm not sure about the drag effect.
If you have a large white population, which I am presuming, then to move that number of people would be a frictional aspect. Whereas if the percentages presume that the populations are the same magnitude, right?
I'm not sure. I think your question is related to the issue of absolute numbers rather than percentages. Is that correct? Those were the slides we weren't able to get on, but I could put them up on an overhead if we have had time on those, but I don't know.
But the question makes sense?
I think so, if I understood it correctly. It does make sense. And we looked, but the answer to that is we looked at it, but we didn't have a chance to scan those in. I have overheads. I can show you afterwards if you'd like for me to look at.
Thanks.
One more question?
So thanks for your presentation. It seemed like really great analysis. But I was hoping you could go back to I think it was your first table where you showed some of your results, and you had, the first column was the results from most unit, what you called unit coincidence, or unit hazard coincidence studies, and then you had the other two methods.
Right.
And could you describe again what so jump forward a couple slides.
I think it's the one after this one, Bill.
Yeah, it's one.
Yeah, this one.
Yeah, it's this slide. So what are you comparing in the second two analysis? I was clear that we're talking about like host tracts and non-host tracts with unit hazard coincidence, but
right here we're comparing neighborhoods. So the neighborhoods that are defined by those methods, we're looking at the entire population in the neighborhood. We're not looking at average demographics in the tracts captured by the neighborhoods. We're sort of dissolving the boundaries between the tracts that are inside the neighborhood. So these are neighborhood level numbers or measurements. Does that help?
yeah. So in one case, you're comparing it to the fragments that are outside of that 1 mile.
Yeah.
radius.
Well, in this when I use the word fragment, if you think about taking like a circular cookie cutter, and you press that cookie cutter down, and the parts of the host tracts that lie outside the circle, what we were using was the same mathematical computations, but rather than looking at the proportions of the areas of the host tracts that are inside the circle, we were looking at the proportion of the areas outside the circle and using those as weighting the populations.
Great.
But what was remarkable to us, to me and my graduate students, that even though that approach is so much different than the approach using the 50% areal containment method, the demographics almost come out identical.
Yeah, you got very robust results.
Yeah.
And you showed that they were different than just all host tracts in general, which is really interesting. So thanks for that clarification.
Sure, you're welcome.
Okay, last question here.
I don't need the mic.
Like you do for the TV.
How does like census accuracy fall into play? Like, do you consider? Can you talk about that?
Could you elaborate that question a little bit? What do you mean?
When you're taking into account the types of people in certain areas and regions, and as far as the accuracy of the Census Bureau, like.
Well, let me answer that question I think I know what you're driving at. First of all, I have to be honest. There's no way I can vouch for the accuracy of the Census Bureau. I mean, as in doing demographic research, you try to do the best you can with the best data that you have. So having said that, one of the difficulties that the Census Bureau has sort of introduced over the years is the way they classify the various racial and ethnic groupings. For example, the hardest one to do the analysis with is the Hispanic group, because they just change the way they do it almost every census. So we did this, to be honest with you. What you see here is the end result of a number of years of hard work. So I can't tell you offhand how we tried to resolve that, but we tried to get as close a match as possible. And then in 2000, another complicating factor that does make things difficult for longitudinal analysis is the Census Bureau gave people multiple options to indicate themselves into different racial and ethnic categories. So how did we resolve that? We tried, and I think we were. I don't think that the results that you see are an artifact of that, though. I mean, there's always a little bit of, you've got to, like I say, you've got to do the best with what you have. So it's difficult, but I feel pretty confident of those results.
So if the census numbers are wrong, these numbers are wrong, but on the other hand, there's no reason to expect that the census numbers would only be wrong in the places that you're looking at. So these are probably the best numbers you're going to get, and they couldn't possibly explain a difference that big.